Good morning. This is Deepti Yellanki, Assistant Professor, Haldia Institute of Technology, and today's my topic is building materials, wood and wood products. Coming to the contents, classification of timber, structure of timber, classification of good timber, seasoning of timber, defects in timber, diseases in timber, decay of timber, preservation of timber, testing of timber, wood products, veneer, plywood, etc. Application of wood and wood products. Moving forward, what is wood? Wood is a hard and fibrous substance which forms a major part of the trunk and branches of the tree. So the tree's major part, that is from above the roots, that is whichever part is above the ground, till the canopy starts, that the hard wood fibrous substance is called wood. It can also be defined as natural polymeric material which practically does not age. Does not age? It sounds strange, right? But there are processes wherein we can season the wood and keep it for very long time without spoiling or decay. Wood as a building material. There are two major classes, that is natural and man-made. Natural form of wood is timber, lumber, etc., which is being rapidly replaced by composite wood material, in which natural wood is just the basic ingredients of laminates, etc. The later, that is the man-made wood, is found to be more useful and adaptable because in it is treated chemically, and in extreme climates like wherever moisture is there, we treat the wood in that aspect, and wherever heat and cold cycles are more, we treat it in that aspect. So likewise, what is the requirement, heavy duty or light weight application? So depending on the usability, we use plywood, fiber boards, chipboards, compressed wood, impregnated wood, etc. Many more are there. Coming to the advantages of wood and wood products, wood has many advantages due to which it is preferred over many other building materials. And transportation handling charges are low for the wood. And coming to the availability, it is easily available everywhere. Sound absorption and electric resistance, thermal insulation, these are some of the major aspects why we depend on wood. It is the ideal material to be used in seawater. Wood is a good absorber of shocks, and in areas which are susceptible to these earthquake shocks. So for those areas, mostly they prefer wooden structures. Repairs and alterations in wood are done easily. Just that part is cut and fixed with the other wooden material, so it's easy. Owing to the above this advantages, it is useful, and in buildings and all we use for doors, windows, many applications are there, even for partition walls, many things. Coming to the classification of trees, trees are classified as endogenous and exogenous. This we know because in science and all we have seen these. Endogenous trees which grow endwards, basically the ending from the open ending from where it grows, in that part it grows. For example, you have these palm, bamboo, etc. So they grow very tall. And exogenic trees are the trees which grow outwards, basically big canopies they build with lots of branches and all. And for these are major structural elements. And for this, we have again subdivided into coniferous and deciduous. We'll see what are those. Endogenous and exogenous trees look something like this. Coniferous, basically the shape of the leaf decides the whether it's a coniferous or deciduous. It has pointed needle-like leaves, deodar, fir, kale, pine, etc. They show distinct annular ring. Basically, the annual rings are the rings formed when we cut open the bark. There we see clear demarcation of rings, concentric rings. These are formed when a tree undergoes a cyclic summer, winter, rain, every all the seasons cycle, then a single annual ring is formed. We know this from science, and when we try to count these annual rings, it gives the age of the tree. So these have distinct annual rings with straight fibers and are soft with pine as an exception, light in color, resinous, and lightweight. Deciduous trees have flat, broad leaves like oak, teak, shishu, poplar, and maple. The annual rings are indistinct, with exception for poplar and basswood. So this is about this. Just with in contrast, these are the annual rings which we can see in any tree. Coming to the classification of timber, firstly, what is the term timber and wood? How are these two different? Let's see. The term timber and wood are often synonymous, but in industrial application, we have seen that they have completely different meaning for both of them. For wood, it is hard fibrous material that make up the tree under the bark, and timber, when we specifically use this word, it is used for engineering work. That means it has some physical characteristics which will be useful for the construction. Coming to the classification of timber, on the basis of position, we have standing timber, that is living tree, then rough timber, which is the tree is felled, and then that part is called rough timber. Converted timber, that means it is processed, some kind of chemical treatment or pressure or whatever you use for it. So these are logs of timber sawn into planks, posts, etc. On the basis of grading, selected grade, standard grade, and common grade, these are the three grading classifications. You can see here the defects, amount of defects contained by any wood. On that basis, we divide them into selected grade, standard grade, or the common grade. So first one, selected grade is it should not contain defects, and estimated effect of which tends to reduce the basic strength of the timber by more than 12.5%, by not more than, sorry. Coming to the standard grade, it should not contain defects, the estimated effect of which tends to reduce the basic strength of the timber by more than 25%. That is very high. And coming to the common grade, these are more than 35 to 50%. Okay. Coming to the modulus of elasticity, based on this, we have uh, group A, group B, and group C. Modulus of elasticity in bending about 12.5 kilonewton per mm square. This gives us group A timber, group B from 9.8 kilonewton per mm square to 12.5 kilonewton per mm square. Coming to the group C, it is 5.6 kilonewton per mm square to and below 9.8 kilonewton per mm square. On the basis of availability, you can see X, Y, and Z. We have these bifurcations of timber. These are the three grades, basically on the basis of availability or growth per year, how much it is growing all over. And most commonly 1415 meter cube. This is the highest grown, that is X type of timber. Y is basically 255 meter cube to 1415 meter cube, and below 355 meter cube per year. This is the very rare trees which are used on the basis of durability. Basically, what we do, how do we test this durability of timber, is we take a size of 600 by 50 by 50 of timber, and we basically bury it in the ground, half of its length, and then what we do is we leave it to the natural conditions to, like, show its space on it, And below the ground, what happens is there's effect of water, microorganisms, many things. Okay, water table sometimes, and above the ground, it is cyclic loading of summer, winter. You can say day and night, alternative temperatures, rain, everything. So, and then we see what how well is the timber after certain interval of time. So these observations on the basis of this, we again divide high durability, moderate durability, and low durability. Average life of 120 months and over is high durability. 120 months, less than 120 months, but of 60 months or more is moderate, and below 60 months is low. On the basis of seasoning characteristics, the your timber is again divided into highly refractory, moderately refractory, and non-refractory. So they are slow and difficult to season, free from defects. The highly refractory timbers, and moderately refractory are season free from surface defects if some protection is given, and non-refractory can be rapidly season free from defects. So this is on the basis of cracking and splitting during the air seasoning. So it is divided like that. Then coming to on the basis of treatability, the classification is based upon the resistance offered by the hardwood of species to preservatives under a working pressure of 1.05 Newton per mm square. This is again easily treatable, but complete preservation not easily obtained. Only partially treatable, refractory, or treatable, where very refractory to treatment, and penetration of the preservatives is being practically nil for sides and ends. So these are some different varieties depending on the treatability. Coming to the structure of timber, a tree can be divided into three portions: the crown, composed of the branches and leaves and trunk and root. So the trunk accounts for 80% of the total bulk of the wood that we have already seen. The structure of the timber, visible to the naked eye or at a small magnification, is called macrostructure, and apparently only at the grand magnification, by magnifying, if you can see something, that is microstructure. So macrostructure of the timber can be studied by cutting the trunk into three direction, and the cross sectional and radial ducts, and those parts which actually has to be magnified can be seen. Okay. Coming to the structure of the timber, the bark, coming to the first portion which is actually useful, is the bark portion. This protects the wood against the mechanical damages. Its interior inner layer, that is called the bast. All these things will again see in the next pictures, following pictures. The bast conveys the nutrients from crown downwards and stores them. And the function of cambium is to grow the wood cells on the inside and the smaller bast cells on the outside. The sapwood assists in the life processing of the tree for storing up the starch and other nutrients. The cell in the sapwood are active. The heartwood gives a strong and firm support to the tree. So these are different portions which we can see. At the center of the cross section is the pith, a small area occupied by friable tissues, and it has a thin wall, loosely connected cells. This is called as pith. If the tree is felled, so this pith completely crumbles and rots, and it gets finished up. Okay, it does not affect the wood in its later stage. In the cross-sectional direction, nutrients pass from the base to the heart through a group of cells running at the right angles to the cambium layer and are referred to as medullary rays. We can see that in this picture. Outer bark, we have seen it protects from mechanical damages, and heartwood you can see here. This is the heartwood, this part is the heartwood, this is the pith, this black center portion is pith, the inner bark is this line, cambium layer is this one, and medullary rays are these rays, vertical rays, okay, and sapwood is existing here, and the outer bark is this part. These things can be detailedly seen in this picture and the following picture too. And this is the pith. Coming to the characteristics of good timber. Narrow annual rings, closer the rings, greater is the strength. This is one assumption while we cut the tree, and we can directly see the annual rings. By seeing at the annual rings, these are some of the characteristics which decide whether it's a good or bad timber. Compact medullary rays, dark in color, uniform texture, sweet smell, and shining fresh cut surface. When struck, sonorous sound should be produced, free from defects in the timber, heavy weight, no woolliness at fresh cut surfaces. So, coming to the defects in timber, what are they? Let's look into. First is shakes. What are these shakes? Actually, the annual rings are existing, right? So there are conditions sometimes wherein these annual rings are actually they have a visual what you say contraction or expansion, so that can be clearly visible when we cut the tree. These are separations in the wood between the annual rings. These lengthwise separations reduce the allowable shear strength without much of a effect on the compressive and tensile values. You can see here how it looks like. You can see how these there are cracks in this area. Yes. Then heart shakes occur due to the shrinkage of the heartwood. When the tree is over matured, the cracks start from pith and run outwards towards the sapwood, that is this area. These are wider at the center and diminish outwards. Cup shakes, you can see here, these are circumferential cracks in a curve shape. Cup shakes appear as curved splits which partly or wholly separate the annual rings from one another. It is caused due to the excessive frost action on the sap present in the tree, especially when the tree is young. Okay, so coming to star shakes are radial splits. It runs from outward to inward. Outside outwards, it is wider, and as it goes inside, it diminishes. These are radial splits or the cracks wide at the circumference and diminishes towards the center of the tree. This defect may arise from severe frost and fierce heat of the sun. Star cracks, shakes appear as wood dries below the fiber saturation point. It is a serious fault leading to the separation of the wood when sawn. Shakes are most harmful to the strength when they follow neutral plane of the beam or run diagonally across the tension side of it. In the first case, they weaken the resistance of the horizontal shear, and in the second, they reduce the tensile strength. Okay, coming to some more defects in timber, you can see the rind gall in this photograph. So there are cases wherein people grow these teak wood and all for business commercial purpose. So what they do, they think that if the tree grows straight, then it is very beneficial, and if branches appear at a very lower height, it would reduce the value of the timber. So what they do, randomly they'll just break the branches, which is not a very good practice. When you do that, what happens is, there if it is not properly cut with a saw or something, so what happens is, there's a wound in the formed in the wood, in the bark, and there's a sapwood. It tries to cover the wound after the branch has been cut off in an irregular manner. The newly developed layer not only do not unite properly with the old rot, thereby leaving cavities from where decay starts. So this is major problem. See, you can see how it develops, the interior decay. Coming to the knots, knots are bases of twigs or branches buried by cambial activities of mother branch. The root of the branch is embedded in the stem with formation of annual rings at right angles to those of the stem. The knot interrupts the basic grain direction of the wood, resulting in the reduction of its strength. In addition, these affect the appearance of the wood. This we'll see in the photograph. The dead knot can be separated from the body of the wood, whereas the live knot cannot be. Knot reduces the strength of the timber and affects the workability of the fibers, because they get curved, and you can see here how it is affecting the complete texture, grains, and distribution. You can see there are curved cracks. So this is the major problem in some of the timber. You can see here also how the annual rings are affected. Yes, defects in timber, there are depending on the size, we have pin knot, small knot, medium knot, and large knot. And depending on the formation, round knot, spike knot, etc. Now coming to the quality and occurrence defects in timber, there are sound knot, decayed knot, encased knot, tight knots. Depending on the occurrence, single knot, cluster knot, branch knot, many more. End splits, this is again one more problem. This is commonly seen actually. There are many, like when the complete environment takes a toll on its on trees and all, because it is exposed outside. Basically there could be heavy winds, storms, rains, anything. So what happens, the wood is actually, when it is cut off and it's exposed to the outside environment, so there is evaporation of the sap, and the end grains of the log can be reduced by these can be reduced by painting the exposed ends or waterproofing it or capping it. So these can be done to reduce these end knots and splits. Twisted fibers, you can see in the picture how it looks like. Coming to the upsets, you can see that the fibers are completely disturbed in the center, the transversely during the growth of the tree itself. So this is again a problem. Foxiness, it is a sign of decay appearing in the form of yellow or red tinge of discoloration. Dry rot, it is decomposition of the felled tree caused by the action of various fungus, basically fungus action. Thank you. We'll continue the rest of this in the next sessions, coming sessions. Stay connected. Goodbye.